We already talked a little bit about domain, and we're still in the preamble to calculus, so I'm going to whip through this quickly and just remind you very shortly here with some example problems, because domain will be important later. So in domain, we're looking for the series of x values. And let's say there's a number line from negative infinity to positive infinity. We want to know which values are allowed. Maybe it's this group right here, where the function can exist. Maybe the real function looks like this and then it stops. Or maybe it starts back up again over here and there's x values over here that are legitimate and it goes back that way forever. We will calculate that by looking at what it can't be. That might sound counterintuitive, but I assure you it works. Let's look at some examples because doing the problems is the easiest. In domain, you can either take the square root of a negative number to screw yourself over, or you can try to divide by 0. That's going to do other screw over. These are the two things you can't do. I should take the red out, huh? It's just in the way. But let's just remember, you cannot divide by 0, and you cannot take the square root of a negative number. So if I look at this first, 2 minus 0.4x, is there any way to divide by 0 here? I don't see it, so that's not a problem. And I don't see any square roots. So that means for this question, the domain is going to be all real numbers. There's nothing that destroys it, and therefore all values are valid. That was fast, wasn't it? And it needs to be fast because we want to get through that. How about this one? There's no divide by 0 and there's no square roots. So this is automatically, the domain is all real numbers. So it'll go from negative infinity to positive infinity, and we're all happy about that. So it's everywhere in here. No big deal. What about this guy here? Well, there's no divide by 0, but there's certainly a square root, isn't there? So let's solve for that. We'll say the square root of x minus 5, and you just say equals 0. Because if we want to find out how to get to the square root of a negative number, we want to find where the barrier is, and the barrier is at 0. So if you square both sides and add 5, of course you're going to find that x equals 5. Basic algebra. So at 5, the question is now, when you look at it, you should have thought maybe, in fact I'll back it up for you. Let's not even write equals 0. Let's look in here and we'll do some logic and we'll say x minus 5, if I want to break the function, needs to be less than 0. So that means x is less than 5. If I put a 5 here, all the valid values are going to be bigger than 5 because all the things that break it are less than 5. And you should know what an open and closed hole means. This is calculus. You know, it's not algebra. You should know this stuff, really. This is more of a ramp up to get into calculus. So we'll say here x, if I write it, x is greater than or equal to 5. And then it'll be fine. Now this one is a little bit different. 3x plus the absolute value of x divided by x. There's no square roots, but there is a division by a denominator, isn't there? So if I set that to 0, you break the function. So this is all real numbers, except x is not equal to 0. You see how this absolute value didn't matter? Because that's not a square root, is it? And it's not on the denominator, is it? So when you're looking at the domain, when you want to look at what values are valid, what valid values exist, you only need to look at the square root of a negative number, and you need to look at the divide by zeros. That's the entire lesson for domain. It's that fast.